Assalamu alaikum, dear students of Standard 9. How are you? Hope you all are fine and safe by the grace of Almighty Allah. I am also fine. So welcome back to my physics class. Today I am here to explain some mathematical problems from chapter 6. So let's give your attention to the class. Problem number 1. 1800 joule heat is required to raise the temperature of an aluminum vessel of mass 100 gram through 20 degrees Celsius. Find the specific heat of aluminum. So here heat is given, the mass of the object that is 100 gram is given, and the raise of temperature 20 degrees Celsius is given. So you have to find out the specific heat of aluminum. So for that we can use this formula. We have to remember one thing: when heat is given to any substance, then its temperature increases, and when heat is taken from any substance, then its temperature decreases. So if the temperature is changed after applying heat, so in that case we will find out the amount of heat by this formula, Q equal to ms del theta. So from this formula also we can find out if Q is given, then m is given, del theta is given, so we can find out S by this formula, S equal to Q by m del theta. Here we need to find out the specific heat, that is S. Now we will put the value in the equation and we get the value of a specific heat. So here Q equal to 1800 joule and m equal to 0.1 into change of temperature 20 degrees Celsius, that means 20 Kelvin. So it becomes 900 joule per kg per Kelvin. So I think you understood the math. Now do the next one. Our next problem is a body of mass 50 gram at temperature 120 degrees Celsius is dropped into an aluminum calorimeter of mass 50 gram, which contains water of mass 150 gram at temperature 20 degrees Celsius. The temperature of the mixture is found to be 30 degrees Celsius. Find the specific heat of the material of the body. Here, specific heat of aluminium equal to 900 joule per kg per Kelvin, it is given. So here, at first I want to tell you, aluminum calorimeter. Calorimeter is an instrument by which we can measure the amount of heat. So here, what are given? Mass of the body M1 equal to 50 gram, that is equal to 0.05 kg. Look here, a body of mass 50 gram is given. Then decrease of temperature of the body equal to 120 minus 30 degrees Celsius, that is equal to 90 Kelvin. Look here, the body which was dropped into the calorimeter, its temperature was 120 degrees Celsius, and when it is dropped into the calorimeter, the final temperature becomes, the temperature of the mixture becomes 30 degrees Celsius. So here we can see the body lost heat. So the decrease of temperature of the body is 120 minus 30 degrees Celsius, that is equal to 90 Kelvin. Because you know, when a hot object is dropped into the cold water, then the hot object will lost heat and the cold object will take in heat. So here the temperature of the object whose mass was 50 gram, it will decrease. So mass of the calorimeter, it is also given, M2 equal to 50 gram, that is equal to 0.05 kg. Mass of the water equal to 150 gram, but 150 gram equal to what? 0.15 kg. Specific heat of calorimeter equal to 900 joule per kg per Kelvin. Specific heat of water You have to memorize this quantity. It is very much important for doing math related to this. So specific heat of water 4200 joule, you should remember it, joule per kg per Kelvin. Rise of temperature of the calorimeter and water. Look, the final temperature of the mixture is 30 degrees Celsius and the calorimeter and water both are at 20 degrees Celsius. So its temperature will rise, and that rise of temperature becomes 30 minus 20, that is equal to 10 Kelvin. So we have to find out the specific heat of the body S1 equal to what. So let's do the solution. So here the specific heat of the material of the body is, so here heat lost by the body Q1 equal to M1 S1 del theta, because the object whose temperature was 120 degrees Celsius was dropped into the calorimeter that contains water at 20 degrees Celsius. So here that hot object will lose heat. So here heat lost by the body Q equal to Q1, that is equal to ms del theta. Here M1 0.05, S1 we don't know the value of S1 because we have to find out this value S1, and del theta equal to 90 Kelvin, that I have shown before. So here, and heat gained by the calorimeter is Q2. Q2 equal to M2 S2 del theta. That means M2 is the mass of calorimeter, S2 is the specific heat of the material of the calorimeter, and del theta is the rise of temperature. So here M2 equal to 0.05 kg and S2 equal to 900, because I have given that the material of the calorimeter has a specific heat, and that is 900 joule per kg per Kelvin, and the raise of temperature is 10 Kelvin, and heat gained by the water. So when the hot object is dropped into the calorimeter that contains water, so hot object will lose heat and the water will take in heat, and also the calorimeter will take in heat. So here heat gain will be heat gain will be in two steps. That means the calorimeter will gain the heat and also the water will gain the heat. So here Q3 equal to M3 S3 del theta. M3 here equal to 0.15, here will be a decimal, into 4200 into 10. So now we know heat lost equal to heat gain. That is the principle of calorimetry, fundamental principle of heat, that heat lost equal to heat gain. So heat lost equal to what? Q1, and heat gain equal to Q2 plus Q3. Dear students, when you will do the math, you must put here a decimal. By mistake, it was not given here. So from this calculation, we can easily find out the value of S1, because 4.5 S1 equal to 6,750. Now S1 equal to, if we divide 6,750 by 4.5, then it becomes 1,500 joule per kg per Kelvin. Do you understand the math? Now, problem number 3. Find the amount of heat required to change 0.1 kg ice at minus 20 degrees Celsius to steam at 100 degrees Celsius. Here, some quantities are given. That is, specific heat of ice is 2100 joule per kg per Kelvin. You must memorize this one also. So specific heat of water and specific heat of ice you should memorize, and sometimes it may not given in the question, that's why. So specific latent heat of fusion of ice equal to 336000 joule per kg. That means 3,36,000 joule per kg. Melting point of ice is 0 degrees Celsius. Boiling point of water is 100 degrees Celsius. And specific latent heat of vaporization of water is 22,68,000 joule per kg. So here, now look, dear students, I have told you when temperature is changed at the time, to find out the heat, we will use the formula Q equal to ms del theta. But you also know that about latent heat, when heat is given to any object, at that time, if temperature is not raised, rather the state of the object is changed, that is known as latent heat. So if latent heat of fusion, latent heat of vaporization, these type of quantities are given in the math, at that time you will find out the value of Q by the formula of m into LF or m into LV. That means mass into latent heat. So now look how I am doing this math. So here heat is absorbed in 4 steps. Look here, 0.1 kg ice at minus 20 degrees Celsius to steam. It is converted into steam at 100 degrees Celsius. So here heat is absorbed in 4 steps. What are those steps? At first, the minus 20 degrees degree ice will reach to 0 degree ice. Okay, then 0 degree ice will reach to 0 degree water, then 0 degree water to 100 degree steam, 100 degree water, then 100 degree water to 100 degree steam. So in these 4 steps, the heat is absorbed in the above mathematical problem. So here, amount of heat required to raise the temperature of 0.1 kg ice from minus 20 degrees Celsius to 0 degrees Celsius is Q1 equal to mass into specific heat into rise of temperature. Look here, minus 20 degree to 0 degree. So here, what I am saying, what are you seeing? You are seeing that temperature is changed here. Temperature is changed from minus 20 to 0 degree. So here mass equal to 0.1 kg, then specific heat equal to ice's specific heat is 2100 joule per kg per Kelvin, and rise of temperature 0 minus minus 20 Kelvin. So it becomes, you can put it here. At last we will solve it. Then number 2, amount of heat required to melt 0.1 kg ice at 0 degree Celsius to water at 0 degree Celsius. At first, minus 20 degree ice to 0 degree ice. Then 0 degree ice will reach to 0 degree water. So here look, there is no change of temperature, but the state of the object is changed. That means from ice to water. So here we will find out the heat by this formula, mass into specific latent heat. So here specific latent heat of fusion will be used. So Q2 equal to mass into specific latent heat of fusion, mass here 0.1, and specific latent heat of fusion equal to 3,06,000 joule per kg per Kelvin. So it becomes 33,600 joule after calculation. Now, number 3 steps. Amount of heat required to raise temperature of 0.1 kg ice from 0 degree Celsius to 100 degree Celsius. So here Q3 equal to, again here we are seeing that temperature is changed. So specific heat into rise of temperature, that means Q equal to ms del theta. We will use that formula here. Here mass equal to 0.1, specific heat of water equal to 4200, because here already ice reaches to water. That's why here the specific heat of water should be used, and 100 minus 0 Kelvin. 42,000 joule. Amount of heat required to convert 0.1 kg water at 100 degrees Celsius to steam at 100 degrees Celsius. That is the fourth step. That means in this step, that water at 100 degrees Celsius will reach to steam at 100 degrees Celsius. So again, we are seeing here that temperature is not changed, but the water will reach to steam. So here, state of the object is changed, but the temperature is not changed. That means here latent heat of vaporization is used. So here Q4 equal to mass into specific latent heat of vaporization. Mass equal to 0.1 kg. Then specific latent heat of vaporization is also given in the question. That is 22,68,000 joule per kg. That becomes 2,26,800 joule. So therefore total amount of heat, because I have already told before doing the math, where heat is absorbed in fourth step. So in those fourth step, what amount of heat should be used, we have already found out that, and now we will add those amount of heat to find out the total amount of heat. So let's look. Q equal to Q1 plus Q2 plus Q3 plus Q4 all together is the answer. Okay, so you have to remember, again I am telling you, when temperature is changed, that time mass into specific heat into rise of temperature. But when temperature is not changed, rather state of the object is changed, at that time heat equal to, that means Q equal to mass into specific latent heat. Okay, so dear students, these are the three maths that I have explained today, and you must practice more maths from the test paper. Test paper you can collect from the previous year, and you should practice. So today I am going to finish my lecture, and the chapter is also over today, and in the next content I will start the new chapter, that is sound. So till then, stay safe and stay strong. There is a nice moral for you. The key to success is to focus on goals, not obstacles. Goodbye everyone.